aircraft is one of the most advanced inventions. Today, aircraft manufacturers are more capable than ever of producing a safer and more reliable aircraft. However, there is one part of flying which is often said to be the toughest, which is the landing. Although modern day aircraft are capable of handling landings very well, there is almost some kind of uncertainty to it. From the time the aircraft turns around and taxis to the active runway, everything seems normal. The consequent power up of strong modern engines makes the aircraft capable of taking off nowadays rather easily. The remaining part of the flight is comparatively challenging. The possibility of experiencing bad weather, an engine failure, or strong winds is unpredictable. However, every aircraft has to somehow and somewhere touch down safely. The main question remains: how does an aircraft stop after landing? On any given modern aircraft, there are mainly three types of braking sources: ground spoilers, disc brakes, and thrust reversers. The three combined can provide the most potent braking effect post-landing. Although spoilers and wheel brakes are an integral part of the aircraft, thrust reversers are usually more common in airliners. One of the most effective and logical ways of bringing an aircraft to rest is by first cutting off its supply of lift. Spoilers on the top of a wing act as a hindrance to the streamlined flow of air. However, spoilers can have varied applications. They can be used to some extent to lower an aircraft's speed at the time of descent and approach. This stage is called partial deployment of spoilers. After touching down, the spoilers take a fully vertical shape by stranding straight out of the wings. In many cases, an additional ground spoiler, which is closer to the fuselage, is used as well. However, there is only a bit that the spoilers can do. The main application of an aircraft spoiler is to cut lift and provide some sort of a drag. The rest is done by disc brakes and reverse thrusts. The wheel braking system is the most common form of braking on any given vehicle in the world. Unsurprisingly, an aircraft has it too. Nevertheless, the braking system on any given aircraft is highly engineered and sophisticated. The complexity of a disc braking system is such that it is hard to explain it in a few words. Simply put, the disc braking system of a wheel is a part that is fixed and doesn't rotate with any other part of the wheel. Just like a pad on any modern vehicle, these stationary discs act as a friction to the rotating part and cause it to either gradually stop or reduce its rotation speed. Most modern aircraft are nowadays equipped with auto braking systems controlled by the autopilot. Depending on the various aspects of landing, the level of the auto brake can be changed to get the desired effect. A lot depends on the length and state of the runway. For example, it will take some tough braking to stop a Boeing 747 touching down on a wet runway at the speed of 290 km per hour. Runway length is an essential factor too. Airports like Kai-Tak, which had a really tough approach and a high possibility of crosswinds, required an aircraft to apply strong brakes to stop on its short runway. For this reason, most pilots nowadays have to prepare the auto braking system before landing. After the aircraft has slowed down to an extent, the pilots switch to manual braking. Thrust reversers are a very common part of modern aircraft engines. The application of thrust reversers is most important in heavier aircraft. Some smaller aircraft like the BAE 146 still don't find any use of thrust reversers. This might have to do with a combination of a strong braking system and effective spoilers. However, on heavy passenger aircraft like an A330, thrust reversers are very crucial. The working of a thrust reverser is easy to understand and very practical. It is the process of amending an already working engine. In modern high bypass turbofan engines, more than 90% of air is sucked in and thrown out of the engine. After touchdown, all thrust reversers have to do is just to change the direction of the air they output. Instead of pushing the air towards the back, the reversers pave a sideward opening to allow the air to push forward. This creates an opposite thrust and this helps the aircraft in stopping. Unlike the process of wheel braking, thrust reversers are mostly manual and can be applied after the aircraft has safely touched down. That's all for today. Thanks for watching and be sure to subscribe to this channel.